Hi, my name is Brian, and I'm going to hack on some Tiger Beetle. Give me one second here. I didn't press all the right buttons on my doodads over here. Now I'm better. My name is Brian. I'm here to hack on some Tiger Beetle, specifically the Tiger Beetle Rust client. Tiger Beetle is a financial database written in Zig. It has clients for all the languages you might want to use, but not Rust, so this is a stream where we are fixing that, making a Rust client entirely on stream front to back. We've been doing this for months and months and months and months and months now. At this phase, we are almost finished reworking our first initial PR. So just kind of the MVP for this client. It's a very simple project, but doing it on stream is really stretched out the time frame here. But this initial PR, we've been doing some rework also for months now. We're almost done with all that rework. So we're at the phase where I am merging in main again before asking for a final review because some things that have impacted our code have changed on the main Tiger Beetle branch. Now this last stream we did a few days ago, days being back there apparently, I started doing the merge and we worked through a bunch of it, and we were at a point where we had triggered a whole bunch of build errors due to changes to the type system. And also, we had one big kind of structural change to make that was somewhat unsafe that we have to do. And if we do it wrong, we will just screw up without ever knowing about it, perhaps. It'll just be undefined behavior. So today on this stream, I don't have huge ambitions. We're going to keep working through that merge and solve some of those build problems. Well, hopefully solve all the build problems and get the merge done. And then we'll go from there if we get that far. Let's go on ahead and get to it. So here's our code over here. Make sure you can see me or see the code. Doesn't matter if you see me. There's the code. And you can see here we are on a temporary branch here that we haven't pushed to our PR, and we've got a bunch of temporary commits. We did our merge right here, and then that merge resulted in a bunch of stuff to resolve, and we've been just kind of poking our way through resolving them. The underlying change that we ran into, let me open the code real quick. Tiger Beetle source, clients Rust, source lib. That'll get us in the ballpark of where we need to be. The big change that impacted us was that the underlying TB client library, which is a library written in Zig that is used by all of the client languages, we just had a few changes. And in Tiger Beetle, we have code generators that introspect that TB client library and output Rust and Go and Java, etc. And so I had to kind of go compare what had changed upstream to what I had already had on my branch, and just kind of make the equivalent changes to the Rust code generator, and then deal with the fallout of all those code gen changes and the API changes in TP client. The big scary thing here is that this is all around FFI bindings, and there's not a lot of guardrails here. So we have to think through this pretty carefully to make sure we don't make any major mistakes. And let's go ahead and I'll go ahead and open up our bindings generator for Rust, which I think is in somewhere here, Rust bindings. Here's our bindings generator, and I'll open the C bindings generator too that we are cribbing off of. I don't know if we're going to actually need to revisit the bindings generators today. Probably not, but we might want to use them as a reference. And then we can also open up our generated code here. So this is generated by this file on the left. And as we're working through this FFI stuff, we often need to cross-reference basically this big generated Rust file here. Now, here's our library, and fortunately, this was several days ago we worked on this last. I had the foresight to write down a few to-dos for myself here. Yeah, okay. So the big two changes in the API were that the TB client type, which is kind of the handle to the client object in the TB client library, it changed slightly. It was an opaque type before and it's an opaque type now, but the definition of that opaque type has changed and the semantics around that opaque type have changed. Before, it used to be a void pointer, basically. And now, if we go look at it somewhere in here, you can see still something that we are not allowed to look into at all. It's just a thing, but it's no longer a void pointer. It's a value type with an array of pointer-sizey things here, U64s. We're not allowed to know what these are from the client's perspective, but they look suspiciously like 4 pointers right here. And I haven't even looked deep enough to actually know what is in this opaque array right here. And it doesn't matter to our purposes. But before, you can see I've not changed this definition at all. This is how it has always been defined. And before, this itself was a pointer type. So a pointer to something on the heap, something opaque on the heap. But now, this is no longer a pointer itself. It's just a value type. So now it is sitting on the struct. And if we look at this documentation for this struct, it has very strict requirements around like what we can do with it. And it says it must be pinned. So we shouldn't copy it and we shouldn't move it. Because we're going to be handing out pointers to this thing to the TB client APIs. So we are responsible for creating this thing and controlling where it is, but we're going to be handing out just wild unsafe pointers to it. And so what we want to do probably is just put this thing on the heap, and that will effectively pin it. It's just going to live in that one spot on the heap forever. And then we will basically not allow the Rust client to be copyable. So, well, we might make the client copyable. It's not copyable, probably clonable. But anyway, this client will live on the heap in one place forever while we hand out unsafe pointers to it. Other big thing that changed is that our functions all started returning statuses. You can see the constructor here. The constructor returns an init status. This is also another type of constructor that we don't currently use in the Rust bindings. And then these non-constructors return TB client status. And these two status types used to be one status type, and they've been split in two for two different purposes. You know, different set of errors possible during the constructor than during regular usage. And now every single function returns a status. And the reason for that is because this TB client handle can be invalidated. And that was kind of the big underlying change upstream, was that it was kind of having a more sensible semantics for how the TB client is destroyed. So you can destroy it and the handle stays in existence, but any future calls to the handle seemingly will return some kind of invalid status. So I think the next thing, so those are the two big things we're solving here. Well, kind of three things. Changing exactly how this is handled, checking all these error codes, and then splitting this previously one status type into two status types. So the next thing we do is probably just go refresh our workspace and make sure it's all primed and built and ready to go, and start looking at what the errors we're seeing are. Refresh our mind about what the error cases are. So I need to go just get into the Rust directory and make sure our workspace is clean. And I'm going to do a cargo check and cargo test. Cargo test is not going to get very far because this thing doesn't even build right now. But generally, every time I sit down to start fresh, cargo check, cargo test, get all those dependencies built and ready to go. All right, So now I'm going to just run cargo check again, just to see these errors. This is a warning. This is going to go away. This is just fallout from all these later errors down here. These are all these status values, basically status codes. All these names have changed slightly because this one status type split into two status types. And kind of we got to decide how to proceed now. Do we change how this TB client handle is dealt with inside of the client and kind of resolve all these hard errors up here? Not hard as in difficult errors up here. Or just go deal with these status values. And I'm inclined to actually just go get rid of all this noise first. This is just simple mechanical renamings. And let's see, right now I'm looking to see whether all these are taking place in the conversions file or if some of them are elsewhere. So this is all in the conversions file right here. All right, all these errors are warnings. These are warnings, but really these are warnings. But this is really kind of it's not an error, it's a warning. But these are a bunch of match cases in Rust. And these are trying to match on constants. And this is kind of an unfortunate corner case of Rust's match semantics. It's trying to match on constants, but actually these constants don't exist. And so it's just kind of binding this name right here or something like that. Yeah. Matches any value. I think this is creating a named binding, and it looks like it's trying to be a match. And all these are unreachable because the first one of these is going to, bind that name, fall into this branch, and then all these other cases are just unreachable. And so the compiler does its best in this case, but this is just a pretty ugly case, and you just got to kind of understand what's going on here if you're a Rust programmer. The Rust compiler errors are usually amazing, but sometimes they are just doing the best they can. Maybe a future language will be designed even better for producing great errors than Rust is. So the first thing I want to do, I think right now, is go look at these status enums and make sure they are defined correctly, because those errors were about kind of converting from the, let me open this conversions file. These are all conversions, implementing the from trait in Rust, kind of converting from the underlying generated C constants to handwritten Rust enums. And so the first thing I got to figure out is whether I have already done the work of splitting that one status enum into multiple status enums. And this is not the status enum I'm looking for. That is also not the status enum I'm looking for. Packet status. I don't think that's the status. I think the issue here is that actually enum status, this status is now two different statuses. But let's go ahead and look at one of these, line 135. See exactly where the error is. Yeah, okay, so it is in this conversion of status. So if we look at TB client again, you can see that we have two enums here. This used to just be called TB status, just one status type. Now we have two, TB init status, TB client status. So the thing you have to do is take this status and actually make this two different status enums. It's kind of the first thing we have to do. And to do this, I'm just going to leave this old one in place and create two new ones, then do the conversion over and then delete the original. So this I'm going to call init status. And I'm just going to do text replace on the names here. Not worry about this yet. And then this is going to be client status. And in fact, I can go resolve those warnings without changing all the function signatures. So I can just leave this in place. What did I do here? Oh, I failed to leave the original status in place. Let's back up and start over. All right, here we have 2 statuses, and then we're going to need 3 statuses. Because the REST API we have here is actually still using this status, and we'll just let it keep using that status for now. And then we'll go fix, do this incrementally. You don't need to do everything all at once. All right, so confusing myself with all the status enums here. This is the first one. We're leaving this one alone. Here's the second one. This is going to be init status. It's going to be client status. And then now I'll go ahead and rewrite all these enums. I think I need to look at TB client. Yeah, this file, TB client RS, the generated code. So somewhere in here, there's probably TB init status. And you can see these are just constants, just codes, integer codes. So for init, we have success, unexpected out of memory. And I think you can see the first one here is success. In the REST API, we have handled this as a error result. So this init status is actually kind of an arrow type. And so we've elided the success variant here and treat that as a result OK in Rust. So these might all be exactly the same still. We have unexpected, out of memory, address invalid, address limit exceeded, system resources, network subsystem. Okay, so these are all the same. For init status, use is the same as status used to be. And then we have unknown here, and that's just for the conversion between these untyped error codes into this enum. Like the network could send us like a status we are unaware of. So we have to account for that in the API in some way. We could also just panic if the API sees an unknown error code, but we put it here. And so all these can be the same. This display, you see the status implements error. We treat it as a error, a result style error. And errors have to be displayable. Client status presumably is going to be slightly different. Okay, you can see your client status is much smaller. It's either OK or invalid. And this is just to handle the case where you've destroyed the client and are continuing to use it accidentally. In Rust, I expect in our API it will be structurally impossible to accidentally continue using the API, but we'll still check for it anyway in case we have made a logic error. And this client status, I think this doesn't even come from the network. It's just coming from the TB client library. But again, there's some possibility for error where we see a status we don't know, so I'm going to leave unknown. And then we're going to have invalid. And that's enough for defining those two things. And it's probably not going to be worth rebuilding because we already have so many errors. But I'm going to checkpoint that little bit of work. And then I'm going to look at our conversions. And again, for now, I'm going to leave the status conversion. Let's see, is it the only conversion here involving status? Yeah. So these are our errors. And again, I'm just going to leave this one here. But none of these constants exist anymore. So I'm just going to blank that out. And that's going to get rid of all those warnings we were looking at a second ago. Actually, I'm going to undo that real quick because I want to copy this and reuse this pattern 2 more times. Now we can empty out this function. And now here we have init status and client status. And again, this merge we're doing right now is very complicated. It's made much more complicated by the fact that this is all FFI stuff with a very weakly typed. A lot of Rust merges, you can just have the compiler, direct you to what to do. But here, because we are dealing with these weak typing across the FFI, we're kind of having to make some big shots in the dark and hope it all works out in the end. So far, it's been going okay. Okay, here's our init status. And again, these are all the same cases. And you can see here, we never expect to see the success case because that's handled elsewhere in the error handling. And this is TB init status. And I think, oh, that's not everything we need to change here. Just doing some textual replacing. And this is TB init success. That looks correct. And client status, only 2 cases. Interesting that we have success is the OK case in one of these types, and then OK is the OK case in the other type. It's a little confusing. But here we only have 2 cases. And one is TB, well, I think you probably can't see this on your, I think it's behind my head. TB client status is what we're looking at here. Client status, client status. And honestly, depending on how we handle these checks, we might not even need this conversion or this enum. Because again, we're never expecting to see client invalid. So we might find that this is just used internally in our API, and we make an assert that this is always client OK, and we might end up deleting this at some point. This is OK, and again, according to our current pattern here, we don't expect to see this, or invalid. That looks correct. All right, now if we build this, we should have gotten rid of a lot of those warnings. I think we'll be able to get through this pretty fast. Oh, this is just rerunning the build script right now. So I had that running through a pager, and it was hiding this last line for some reason. Because this is, you can see that the way this pager, or the way the cargo works here, it prints this out and then backspaces the cursor all the way back there. So I guess the pager decided not to show that yet. Or maybe because cargo sees that it's running through a pager, that it's decides not to do that dynamic terminal stuff. Future highway, TB client second half. What does that mean? Did I screw something up? Or are we just saying this is part 2 of the TB client saga? All right, what does this look like? Actually, let's just go look at it right like that. TB create transfer result transfer OK. Typo. I see what you're saying, future highway. I wrote these incorrectly. TB client status TB client. Gotcha. Thank you for the help. I appreciate that a lot. All right, if we go back here and run this again, it looks like there's some more renamings that have changed here. All right, let's run this to the pager. And I am guessing that the code generator, because this TB client, the create transfer result is still here. It still exists in the API, and I don't think it changed. But I'm guessing the code generator just changed, and maybe these names are different now. All right, what is this? TB create transfer result. TB create transfer result. TB create transfer. Yeah. Wait. Amount must not be 0. Let's go look at that error. Line 86. Oh, maybe some of these enums have, some of these status codes have changed, maybe. Specifically saying this one is unreachable. Unreachable pattern. Matches any value. All right, so this matches any value, and that means everything after it is unreachable. So this amount must not be 0. Maybe that changed in the API. Right, I talked about this a second ago. The match has a semantic confusion the compiler can't understand very well. Or maybe this is a binding, or maybe this is a constant that it's matching against. It's supposed to be a constant, but it seems like the constant doesn't exist. Transfer ledger must not be 0. Transfer. This is pretty gnarly. All right, here it is. Amount must not be 0. The ledger must not be 0. This amount doesn't exist anymore, so closing transfer must still exist. It's right here. Oh, this is a wall of text. This is tough to read. Closing transfer is here. Ledger must not be 0 is a thing still. Is it spelled wrong? I'm going to have to make this text slightly smaller for a second, chat. Sorry about that. Oh my gosh, look at this. Ledger must not be 0. TB create transfer. TB create transfer result. TB create transfer. Ledger must not be 0. It looks like it exists and is spelled the same way. Am I reading this warning incorrectly? This, oh, transfer amount matches any value. So this one still exists. Amount must not be 0, might not exist anymore. And indeed, yeah, right here, between these two, there used to be an amount must not be 0. And presumably, amount is now allowed to be 0. Huh. That is... I'm kind of curious about, like, looking back through the commit history and figuring out, you know, why that changed and what happened here. But presumably just one of these codes no longer exists. They probably just removed the code and said the server will never return this code anymore, because now you're probably allowed to include a 0 amount in the transfer for some reason that I don't know. But I think the thing to do here is just delete this line and then go look at our handwritten transfer result. Create transfer result, amount must not be 0. All those cases are gone. And just because this is a little creepy and I'm afraid we might screw up here, let's just go back to the source of truth and find that enum as defined in Zig. Source might be in Tiger Beetle. create transfer result. You can see these ints are not, these numbers are not always in order. It's kind of what happens with a stable set of error codes, is they just kind of like turn into Swiss cheese over time. Ledger must not be 0, so right here, probably code 18 no longer exists. There used to be a code 18 right here. Amount must not be 0. There's a question in chat about why not use the style mod name then const name. And that's a very interesting question in this case, because that would have prevented this like semantic error confusion. So here you can see when I did these matches, I just imported this whole namespace. And the reason I imported the whole namespace is because I didn't want to, write that every single place. But if I had namespaced this, then the compiler would have had enough information to know that this should be a thing, and it is not a thing. So that's an interesting note for the future. Like, that could have prevented this problem if I had included the namespace or module name in Rust. All right, so anyway, I think we've resolved that problem, but let's see if we run into any more of those. Okay, so that's all of the problems with the conversions. That one thing disappeared. And again, I could go back here, Future Highway, and do that right now, because this is the kind of thing that pretty likely to happen with API evolution. This enum over here is going to change. This set of codes will change. So I could go back and do that prefixing, because it does seem to be probably a better practice. Although I feel like that's a bit of a yak shape at this point, and I don't want to divert from... We're already in the middle of like a situation where the entire code base is on fire. We have tons and tons of errors. Kind of just got to get through it right now. All right, let's run this cargo check again. Okay, I think it's okay. Checkpoint where we are. And again, go see what the state of our errors is. This invalid 153. 153. Right here, again, I did this to avoid just repeating that status everywhere, but this is actually client status that we need to import. This is init status. All right, everything else is related to, we want to get to the point here where everything else is related to the use of that client handle. I'm going to tackle all this other easy stuff first. All right, there's some kind of missing, the fields have changed here. I think we can probably go tackle that before we deal with the thorny issues of how that client handle is dealt with. Yeah, this stuff just doesn't seem to exist anymore. This TB packet type is kind of like, it's the thing we use to communicate the information about a single request to the underlying TB client library. And a lot of its fields are relevant to us, and some of its fields are just internal to the client library. So again, let's go open our bindings and look at our TB packet T to cross-reference over here. Oh yeah, this definition has changed drastically. This used to be much bigger. So here we can probably just go knock all those errors out pretty straightforwardly. 904, that thing just doesn't exist. And actually, we don't even need to look at the errors right now. Let's just, look at the fields we have and the fields they have. And data goes up here. Yeah, this thing has changed a lot. Data size is next. User tag. Uh-oh, I don't know what that is. I'm guessing that is kind of like, I have no idea what that is. Hopefully we don't need it. It's a U16 data size. User tag. It's a U16. I'm going to go ahead and say, you know, put some eye-catching constant there in case that comes up later in a panic message or something. Just mess with my audio a second. Check 1 2, check 1 2. Check 1 2. Something is wrong with my voice. In my cans, it feels like it is panned right. Let me know if it sounds like my voice is panned right to you. I might have hit something at some point. Just give me a second here, chat. I'm just messing with my... I don't see anything like that over there. Maybe it's a problem with my ears. Okay, I'll keep going. Data size. Data. Ah, thanks, Feature Highway. Sounds like it sounds normal over there. I think there's a problem. I've got a very complicated hardware monitoring setup over here, and like, just depending on exactly how I twist the knobs, things... I think my monitoring mixer is not very good. Because I just moved it like a millimeter and all of a sudden my balance is correct again. User tag. Operation is next. That should be the same. Status should be the same. And then all of this stuff, just internal stuff, seems like it is all just buried in this opaque field now. Opaque. And this is small enough that we can probably just say default. Turn it on to zeros. That looks correct to me. Let's see what the compiler thinks. Compiler seems happy with that. Okay, now we're at the hard spot. Now, kind of, we need to decide what to do next. Whether we're going to change how this is stored internally and all those related errors here. These are just all related to the change in representation of this field. Or deal with the API changes that all demand checks for the status. And remember, we still have this vestigial status type down here that shows up in our API that is, this is no longer makes any sense. I think the thing to do is, I kind of want to get rid of that status thing and just deal with the consequences of that. We might end up throwing into some to-dos or panics to-dos where that creates holes in our implementation. But I don't really love having that hang around anywhere. But we've already committed, so if this is the wrong decision, we can come back and fix it later. But I want to kill this thing. I don't want that to be around anymore. And again, we have conversions over here. Get rid of that. And basically up here, we have statuses. And these, let's go look at our API again. This one is an init status now. And this might all just start working immediately just by changing the names. And here we're checking for, it looks like we've already fixed this name. That name looks correct to me. And this conversion will probably, there's no type info here, it's all inferred. This might just work by changing that name. That might be enough. That might be sufficient. I don't think status is used anywhere else. These are all a different status. Okay, let's build that and see if it gets us a little further. Seems to be pretty good. Okay, now the hard thing. This, because according to our docs, it needs to be unmovable, but also we're handing out unsafe pointers to it. So this needs to basically end up like this. It's kind of a bummer. I hate like having unsafe fields. You know, it'd be much more pleasant to have this. But we can't have a box because we can't alias that box. So this is what we need to do. This just needs to be an unsafe pointer, and we need to remember to deallocate it in the destructor. You have to coordinate that deallocation with the calls to dinit, etc. All right, so where do we create this thing? Right here. It's up null mute. And what we're going to do instead is going to create a boxed default, and then we're going to have that box just convert itself into an unsafe pointer for us. And I don't remember the API for doing that. So let's go look at the webs. .rs box. It might be box forget. It's a pretty good candidate for that kind of an operation. So we're going to say box new default, or maybe there's even a box default. I'm not sure. Here's a box new default, and then tell it to give it to us as an unsafe pointer. So I'm just looking at all the type signatures here, the return types. Not even looking at the names right now, just seeing if I see like a star mute return type. Into raw, that is the thing right there. So we call it into raw, and then it's our responsibility from that point on. Into raw, right? Remember that, y'all. Into raw. All right, so TB client. I'm gonna say box new, and I'm wondering if I need to type hint here. Ultimately, we aren't going to need the type hint probably, because it'll get enough type hints from here. It'll then get inference from later on, but these calls are currently incorrect, so the inference might not work. But what we want is a star mute tbc tb client t, and to get that, we're going to say box new default. Can we actually get a default of that thing? TB client T doesn't implement default. That's kind of unfortunate, but this will implement default. So we can say TBC TB client T. I might do this in a few steps, a few different statements. In fact, I am going to do that. I'm going to say TB client is a box of this, and this field is opaque, and we can default that array. And then we'll say let mute TB client equals, and we don't have to type hint this. In fact, now we don't need to type hint this because there's plenty of type information here. And this is box. If you remember from the API docs we just looked at, this is not a method, it's a static function, an associated function, to avoid accidental dereferencing issues, accidental misusage. This is into raw of this thing. You know, you might expect this to be tb client.into raw. But because lots of things can be dereferenced into boxes, this API is designed so you have to be explicit and say box into raw. And so this should be now a star mute pointer to a TB client on the heap, I think. And then this call, this referencing here is probably not correct anymore. In fact, it is. Let's just go look at the signature of TB client just to see it, or TB client in it. You can see this. Oh, it's underneath my face. You can see TB client in it takes a star mute TB client T, which is the thing we have. Okay, so that is going to take this pointer and fill it in with whatever that opaque data is, so it's a valid handle now. And then we've also got to store that pointer for future use. And this pointer is just going to be shared all over the place in the FFI world, in the unsafe C world. Just don't worry about it. But this function looks basically correct to me. And I'm just guessing offhand that we have a bunch of and mute self.client arguments to the APIs here. I'm not even going to go back and look at any of the errors yet. Just all, oh, that's not right, probably. What is this? What is going on here? Close. In fact, I'm wrong. TB client submit self.client. These are not dereferencing, or not referencing that client. It's a little bit surprising to me. Anyway, this call looks like it'll probably work as written, because TB client submit, I'm assuming, takes star mute TB client, and that is what we have. All right, I am going to go back and get the compiler to help me now. Mismatch types. Okay. Let's go figure out what we're doing on there. Send a client. There's a little, just a tiny little local helper struct. Oh, this is in our close method. So the whole reason these upstream changes happened was to straighten out the semantics around destroying the thing here. So we probably need to think pretty hard about what we're doing on close. You can see our drop method just calls close. So all of our destructor concerns should be right here. I'm just looking at this and thinking about what was I thinking before when I wrote this, and what is the correct semantics now. So probably what this close was doing was sending this off to another thread, because this is a blocking operation, blocking. It's sending this handle off to a different thread, and then waiting for the close to be finished. And you can see here close as by value. So we don't have to worry about what happens if somebody calls close twice. And so this honestly looks like nothing really substantial needs to change here as far as the semantics. Though in the future, I believe we're going to need to be able to make this client a shared type. Like either make it clonable itself or make it shareable in an arc so you can send it between threads. And we'll deal with that when it comes to it. Right now, shouldn't be sendable because it contains unsafe pointers. Although, just looking for like an unsafe impulse send on here. Doesn't look like it. Yeah, so right now this client is trapped in the thread and or task that you created in. Can't send it anywhere. And probably can't sync it to share it with other threads, which is simple for reasoning about concurrency, but it is probably in the future we're going to have to like expand this to make that client shareable across threads in some way. But we can do that in the future, and we'll be writing tests when we make that possible. NockYam, the question is whether closures allocate, and Rust closures come in many forms. They can allocate or they can't allocate depending on exactly how you write them. There's many types of closures in Rust. You can have closures that are on the stack and referenced by reference. So the closure data all just lives on the stack, doesn't have to be allocated. And you just pass around the reference to the closures. And those closures are just kind of like limited. They follow a stack discipline. Though when you deal with concurrency and multi-threading, generally you create a heap allocated closure. And it's just much easier to deal with when you're dealing with multi-threading. But closures are powerful, and they basically give you all the options, a whole menu of options for allocation and capturing. All right, but this struct send client contains a star mute TB client. Does this really contain a star mute TB client? Because remember, we also have to deallocate this now. Before, we didn't need to deallocate this thing. Hi, .0/. Yeah, we're making progress. It's always slower than I want it to be. I'm really hoping we can just finish this merge today. So far, I'm feeling energetic. All right, remember, we have to destroy this thing somewhere, either in this thread or the... Sorry, y'all. Smacking my hardware. All right, so before, what we did was we replaced that with a null pointer just for safety purposes, so we don't accidentally reuse it. And that still makes sense to me, although that means we'll have to deallocate in the other thread, which we probably do need to do. We also have to be sensitive here about like what happens if the other thread doesn't finish or if some message isn't received. We want this deallocation to happen in all situations. Like this down here is a future, and it's very possible that this future will just be dropped. And in fact, I think that is probably what our drop implementation does right here. Like, you know, fire off that destructor in a different thread and forget about it. So we can't do the deallocation here because we might leak it. So this is actually pretty awkward. You kind of hate to allocate something on one thread and deallocate on another thread just for understandability. And because, you know, sometimes there are some software that doesn't like doing that. But it looks like we're going to have to do the deallocation right here. Looks like we'll have to do the deallocation there. All right, so again, I want to just null out this pointer, and I need to think a little bit about how to do that. I probably don't need to do a replace here because you don't have a by value handle anymore. But I'm actually not entirely sure. There's several layers of pointeriness right here. This looks to me like this will work. It's going to replace our pointer with a null pointer and then give us the pointer to stick into this send client object. And this all looks more or less the same. Call TB client dinit, and let's see what dinit expects. Star mute pointer. That looks right. When we drop this transaction, that is this transmit, not transaction. TX here means transmit. When we drop this handle, this is the channel handle, that is the signal for the future to proceed. So right here, we got to do the deallocation. So to do that, we're going to have to convert this unsafe pointer back into a Rust box. And this is probably from raw, based on the naming of the into raw that we created the unsafe pointer with. From Fram. Sorry, let me lower my mic. I'm creating a lot of pops right now. From raw. Client.0. And then as soon as we do that, you know, the box will deal with the deallocation. So I'm wondering if we want to, so if we do this right here, this will actually be deallocated here after this drop. And I'm thinking like whether we want to force this deallocation to be right here. And I kind of think we do. Let's get all of our work over with before we send the signal to the other thread. And to do that, we can say stood mim drop. There's all kinds of ways to force this deallocation, but that is one of them. Okay, that was a lot of fiddly little unsafe code to write in one go. Let's see what the compiler is thinking right now. All right, and now we've got the errors down to just one screen. That's progress. I'm looking right now to see if any of this stuff looks like new problems we've introduced, and this is one. That from raw is an unsafe function. So we actually, we can do this. I'm actually wondering about this. This is a scope, this block. This is an unsafe block. So this should be dropped right here, I think. I'm going to put a drop me. Actually, when you really care about knowing exactly when things are dropped, it's worth being explicit IMO. So I'm still going to say, oh, there's an unsafe block right above this. Let's use that one. I'm still going to say stood mim drop. Some reviewers might not agree with that, but in the Rust world, sometimes you really care about knowing exactly the scope of things. Yeah. All right. Let's see what is going on with this other stuff. Oh, this all looks easy. We've seen this before on the last stream. This completion callback has changed slightly. Let's go, let's checkpoint our work. And line 54. And let's see, this should tell us exactly what to do here, more or less. One of these arguments changed. I think this TB client T is no longer an argument to this on completion. On completion, what is that? It's probably just a free function way down here. No longer takes this client. Okay, and that feeds into all this completion does for us. This is what happens for us to get feedback on a request, and this always happens on some other thread. And all we do is send all this data back to the main thread to deal with it later. But this callback that we're calling, we're using the user data field of the packet we saw earlier to hold a callback. And that's probably a closure in our case, just an unsafe pointer to a closure. And that callback no longer can take a client because that client doesn't exist. And that callback is this type. So this TB client no longer exists. And somewhere, probably in those callback closures, they're using this completion message type just to package up all these arguments and ship them back to the other thread. So that client doesn't exist, and you can see we weren't even using it anyway. It's got a prefix with an underscore on it. Let's see who is using that completion message. And this is one of our nightmare generic helper methods. Right here, that client doesn't exist. And this is the on completion closure. That client doesn't exist. And that is probably everything. Again, this is all very gnarly, unsafe FFI code, but seems straightforward. We'll see if this all crashes once we actually finally get to run a test. All right, one more, line 50. All right, this cluster ID changed. The representation changed. Let's see what the error says. Expected 16 bytes, found a pointer to a byte. So cluster ID, okay. So in our API, pointer to a byte. Oh, because we're casting it to a byte. Yeah, okay. So before the underlying API was just expecting us to cast this to a pointer. Now it's literally expecting an array. That is probably sufficient right there. This 2 LE bytes almost certainly is creating a 16 element byte array from our U128 that is in our Surface API. Let's see if that works. Getting close. This literal is out of range for a U16 ABC. Oh, too many digits on that literal. I feel like you could have caught that, chat. All right, 2 bytes there. We still don't know what this user tag is. I'm guessing it's for some purpose, like some tracking purpose that we are using Rust closures for. And again, I just put this eye-catching literal right here in case we see that later in a error message or a panic message. Okay, almost there. That doesn't need to be mutable anymore. Oh, we're tantalizingly close. Oh no. Oh no! Oh, this is frustrating. So this array, Rust doesn't consider that to have a defined ABI. Wow, this is rough. All right, let's checkpoint and right at the finish line. This is like a hard problem. This is a hard problem. So the API, as it used to be, was good for us. And the API, as they've defined it now, is bad for us. But maybe our code generator is just wrong. So they're saying, what is this? TB client init. This is a 16 element array. What is that in C? What is an array in C? Do you have like arrays of defined length in C? I think this code generator is basically wrong, and this should still be a star U8 pointer, because an array in C is still just a thin pointer, right, y'all? This is where I could use some help. All right, let's go back to our code generator. I think I probably just flubbed writing the code generator here. Rust bindings, and then TB client header. And in fact, the code generator, if you'll recall from previous streams, for the function definitions, is not an actual code generator. It's just splatting out handwritten definitions. Yeah, so in C, this is a 16 element array, but I think that just decays into a pointer, right? Future highway, U128s are also not ABI safe in Rust. So this API has changed several times, and originally the ABI did call for just passing by value a U128, but that is not ABI safe in Rust. And then it changed to a pointer to a U128, which is good. And now it is a 16 element array. But I think in C, this is like the underlying ABI, this is still just a pointer, I think. Even if something is not ABI safe in Rust, I mean, you shouldn't do it. But oftentimes the ABI is basically stable. Or basically stable on platforms you care about. I think this is still just this. I think I just wrote the code generator wrong. And I'm not even going to go ask ChatGPT and or a search engine. I think in C, an array is just a pointer. Okay, so we've changed the code generator. That should just automatically rerun. You can see our build script is running. And if we're wrong about this, it should show up in the test pretty fast. It'll either crash or we will be giving the wrong cluster ID to the server and it will send us an error. Oh, but we still need to, no, okay. It's not a U128, it's a pointer. It's a pointer to 16 bytes. Yeah, I didn't change. I still think this is not quite right. I think the definition we wrote here is correct. But this, we don't want to just blindly cast this pointer. What did I say here? No. All right, let's back up. I think this is wrong. It's still a pointer to 16 bytes. It is not a pointer to a U128. We do need to convert it to bytes first. On a little Indian machine, it might be the case that we don't need to convert it to bytes first actually, but semantically we should. It's a pointer to 16 bytes. I think, yikes, I kind of don't know the Rust type system well enough to say what this thing is. This is not a fat pointer. The size of this array is known at compile time statically. This is a value type. This is a thin pointer to an array with a known size. I think this is what we want. So before, is this exactly what we had long ago? This might be what we had before we did the merge. This might be exactly what we had before. And I just kind of blindly followed the changes in the C generator. But this, now I think this is what we want. And then whatever I did over here, I want that. But I still want all that. Okay, I think that is still it. I think that's still it. Oh, before it was a const U8 array. Oh, it was a pointer to U8, not a pointer to an array of U8. Yeah, .0/. It's also very easy to make something that works but is actually not correct. And like there are different degrees of not correct with bindings. Like sometimes not correct is fine. Sometimes not correct is fine on every platform that you will conceivably ever run on, but not correct on some platforms. And sometimes it's just silent, undefined behavior. And sometimes that'll never even be a problem. Okay, these are mutable bytes. Are these really mutable bytes? No, these are constant. Okay, my bindings generator is still wrong. This is a star const. I think this is a star const. This says, again, my knowledge of C is a little lacking, but it does have the const keyword here, so I'm guessing that is a constant pointer. This is the one. This is the one. Hey, there we go. Okay, I'm going to commit this all and run our one teeny tiny insufficient smoke test to see if this seems to still work. But I think we've done it. I think we've done it. That all went pretty well, honestly. That was a pretty tough merge. It took like 4 hours of streaming time. Ah. Okay, now we got to clean up this history, make sure everything is still in good shape, and we can push that back to the PR. That went pretty great. I'm pretty happy with how that went. So all this stuff just needs to be squashed down. I know, only one test to deal with. Like if we had more tests, we just have to go fix all the tests. It's a good thing about not having tests. Don't have to worry about breaking the tests. Okay, I think this is everything. Rework, fix, merge, fallout. So again, I'm pretty happy in this case to make this merge not be like the full merge. Like this commit is broken. The merge commit is broken. But like there was so much work fixing this merge that I want all that work to be just kind of like on its own. And yeah, we got all kinds of problems with the source code. Let's go fix all these spaces, clean this up and make it presentable. So our Rust bindings line 189. Where is that? Not 189. If type mappings.lin. 189. 189. Oh, yeah, right there. That's it. All right. I'm sure there must be some Emacs configuration that'll just make all these end-of-line white spaces go away. I don't know what it is, though. Init. Okay, that's all the white space. Let's just give it another visual inspection. That to do can go away. This all looks good to me. Okay. And now we'll see what the tools think. Just one formatting change. And Clippy. Ooh, that was pretty good. Got to decide now if we're going to keep going. It's been 80 minutes. Next thing to do, really, the next thing to do is look at the PR and see if we've gotten any more feedback that needs to be addressed. And then there's all the CI stuff on that PR. The CI has been read the whole time, and I haven't even looked at it. All right, git push. And we can go over to the PR and tell our reviewer that we've merged. Let's refresh this. And in fact, I probably should have. Let's go back real quick and do another quick merge with main and see if we can collapse those two merges into one merge. Because that merge was from several days ago now. Git fetch origin. Git merge origin main. test. And really, it would be nice if we could merge. Now that we have merges in our history, the history is pretty tough to read. Oh, this is somebody else's code that I don't care about. Yeah, I don't love merges generally. We could rebase this. No, we can't rebase this. That merge is going to be the way it is. Too tough to rebase. Yeah, we're just going to have 2 merges. It'll be fine. We'll probably have even more merges before this is finally merged into main. And I think Tiger Beetle does the common squash and merge, so it almost doesn't even matter what our history on this PR looks like. Okay, now I can tell our reviewer merged with main. And then next I'll see what's wrong with CI, but this is almost done. Let's go see if our reviewer said anything new. Okay, we've got some new feedback. So this is from 2 or 3 weeks ago now. We changed the representation of several of the surface level structs in the API to have ABI compatibility with the underlying Zig types. Commit the generated TB client. This file and is host and target independent, so no reason to run. Yeah, I mean, we'll need to include the bindings in any package we publish anyway. No need to run build.zig. Yeah, so if we commit this, so it's easy enough to commit this. So what he's asking for is that our generated code created by our bindings generator should be committed to Git, which, you know, it's fine. It's kind of, some projects do, some projects don't. But there's also another stipulation here, is like no need to run build.zig every time someone builds the client. And that'll certainly be true for a package coming from crates.io. We're not going to do any Zig builds for that. But I'm not sure if the way our build system is set up will actually avoid running that build. Anyway, I don't think it matters too much anyway. I'll, commit that as asked, and that'll be that. So let's go back, and there's probably a git ignore specific to the Rust client. Right there, you can see it's ignored. Just unignore that. Git add, git commit. Commit generated tb client.rs. Git push. Oh, I didn't want to do that. I'm guessing that Clippy is going to hate that. Cargo format's probably going to hate that. Let's see what those tools think about this generated thing. Yeah. Can we tell cargo format to ignore? I think we can. Eek, okay. Let's go ask ChatGPT how to do that. Oh, I forgot to show you my screen. Sorry, y'all. Anyway, we're going back to the webs. We don't need the standard library. We need, I can probably just ask whatever search engine I have how to do that. How do I tell Rust format to ignore a module? Rust format skipped. That's the whole thing. Go back to the code. And we don't need to put it directly inside the module. Instead, we can just tag outside the module. Not that, that is not the module. This is the module. That. You can see we've already got all kinds of stuff here. But in fact, I'm thinking about whether any of this stuff can be removed, but I don't think it can. All right, that looks right. Diff, cargo check, cargo check. Over here we can say cargo fumped. And now cargo format has not touched our generated code anymore. We're going to mend our previous and force push. We still need to run Clippy and make sure we tell Clippy to not pay any attention to this. Cargo Clippy. Or maybe Clippy will just be happy with it. I'm going to go real quick. I'm not going to show you, but I'm going to go see if I can open any of those CI reports yet. No, it's all rechecking. I should have opened those CI pages before I pushed. Right now it's all spinning and rebuilding the CI. Now Cargo Clippy is happy. Okay. We can go back and tell our reviewer that we have resolved that other thing he asked us to do. I've committed tb client.rs. And that one's resolved. All right, what else? Okay. This is related to exactly how we're massaging the Tiger Beetle error statuses into Rust errors, and our reviewer is happy. Resolved. Futures is our private dependency, and the public API is phrased strictly in terms of async fun. Interesting question. I don't remember exactly how we're using futures. Let's check that out. Don't remember what we're doing. I think we're supposed to be using a futures channel, and he's probably right. He asked if we could just use futures channel. No, I'm using the future trait here. I think this trait actually is, oh no, that's the standard future trait. Futures, yes, we're just using the channel from futures. And it's an internal dependencies. MatClad is one of those people that is very concerned about dependencies. So if we can have fewer dependencies, he's going to want fewer dependencies. And right now we're using the futures crate as a dependency, which is a very common dependency, but apparently there's a crate called futures channel that'll just give us that one channel we're using. So that's easy enough to do. Let's go do that. Again, he's saying we could just have been on futures channel. Let's go to docs.rs. I didn't even know futures channel. Let me make sure this is owned by people that I understand. It's owned by the Rustlang org. Okay. Because I've never heard of futures channel before. But I guess futures internally depends on futures channel. And futures channel, yeah. That's nice to know. So if you just need those the async friendly channels, this crate has just that and nothing else. That's nice. Futures channel 0.3.31. Let's go deal with that. WSL. Cargo. Hopefully we don't use futures anywhere else. Channel, same version number, and library. Looks like we just got to change these 2 colons to an underscore, and that should be the whole thing. Go ahead and run that test again, make sure it all still works. Oh no, we use the futures executor in our tests. Well, we can depend on the executor in our test and futures channel in the main crate. MatCloud will like that. So still have a futures dependencies, but only in the test. So anybody that depends on our crate is only going to pull in futures channel. And let's also make sure he was asking about whether this is part of our API. I don't think it is. No, it's just an internal detail. I'm looking at these futures. These are all opaque types. Like this future, yeah, is just not a channel future. It's just some async thing. It's a synthetic future generated by async 08. Did I run those tests again? I don't think so. Let's run those tests one more time. If commit rework only depend on futures channel push. And again, let's go reassure our reviewer that we have, oops, that's not the right screen, that we have done the thing. Say, yes, it is an internal implementation detail. I have changed the dependency. We still depend on futures as a dev dependency for block on. Resolve. MatCloud really doesn't like dependencies. Oh, what is this? What is this? This is just a test dependency. We'll deal with this some other day. Should I do this? Wow, he really doesn't like dependencies. This is kind of up to me. Not feeling. It's just a test. Do I want to do this right now is the question. 6:42, my time. No, this is a big enough project that I don't want to do it right now. We'll do it next time. Okay, let's wrap. Let's see real quick. See if we got any of our failed CIs. I don't think we'll address them right now, but let's at least look and prime our brains. Zig format on our Rust bindings. That's easy enough to fix. It's the only thing I'm seeing so far. Let's go fix that. But we're going to wrap up soon, y'all. How do we do this? Where's our Rust bindings? Rust bindings.zig. Let's say zig font. Oh, ezig font. I don't have zig in my path, so I do have this. I have my own fork of the zig compiler that I use. Yep, change Rust bindings. What here? Any of this surprising? Not looking super surprising to me. What's that? Don't see what changed there. Maybe just a white space thing. Let's run the bindings again and make sure it's working. I think this is the last thing we do before we wrap up, chat. Right, I'll tell MatClad. Nothing else is going on here in the CI. So it would be nice, you can see here the Tiger Beetle CI has a configuration for each client. Ooh, that's gross. Can I expand this? No. You can see here, like every client has its own, probably, some Docker container that installs the correct tool chain for every possible client. And we have not done that for Rust yet. And this PR would be the appropriate place to do that. And I probably even asked on the initial op, like, I need help doing that. I don't know how to do it. But I think we'll tackle that too. Okay. I'm not going to tackle this last thing, but I'm going to say, almost done. Probably I'm going to add CI for Rust. Okay, well, that all went really well today. So today we, again, part 2, finished the merge with Upstream on our PR for the Rust client. And it was a very interesting merge. All those FFI issues that you don't really have the Rust type system guardrails to get you through. But it all went really well. And I appreciate everybody showing up and, helping me out in chat. That is always very much appreciated. My name is Brian Burson on GitHub, BRSON. I'll be back in a few days to keep working on the Rust client. I'll see you then. Thanks, everybody.